Welcome back to the AI Frontiers podcast. Today, we're diving deep into the exciting world of foundation models and their potential for revolutionizing decision making. Joining me is Dr. Sherry Yang, a leading researcher in this field, and Dr. Phut Naim, a renowned expert in field experts' area of expertise. Dr. Yang, thank you for being here.
It's a pleasure to be here. I'm excited to discuss this cutting edge research with you and Dr. Field X Sem.
Dr. Bear when your insights on this topic are invaluable. Let's begin by setting the stage. Dr. Yang, could you tell us a bit about the historical context of foundation models and how they relate to the field of decision making?
Certainly. Traditionally, these two fields, foundation models and decision making, have operated in separate spheres. Foundation models, trained on vast datasets of text and images through self supervised learning, have shown incredible abilities in transferring knowledge to various downstream tasks. These tasks often involve complex reasoning, control, search, and planning. On the other hand, decision making focuses on learning from interactive experiences within the framework of Markov decision processes, MDPs. This encompasses areas like reinforcement learning, RL, imitation learning, planning, search, and optimal control.
So they seem like quite different areas of focus. What sparked this convergence between the two?
That's a great question. The recent advancements in foundation models, particularly large language models, have made them capable of tackling increasingly complex tasks that require long-term reasoning and interaction with other agents. This has opened up a new frontier for applying these models in decision-making scenarios.
It sounds like a natural progression, Doctor. Do you see this convergence as a significant development in the field of AI?
Absolutely. This convergence has the potential to truly transform our understanding of AI. By bringing together the power of foundation models with the rich framework of decision-making, we can build more intelligent and versatile agents capable of interacting with the world in meaningful ways. This could lead to groundbreaking applications in areas like robotics, autonomous systems, and even healthcare.
Dr. Yang, could you delve deeper into the key contributions and innovations presented in your paper?
Our paper proposes a framework for understanding the various roles that foundation models can play in decision-making. We explore their application as conditional generative models, representation learners, and interactive agents or environments. For instance, foundation models can be used to generate sequences of actions, effectively capturing behavioral priors or skills. They can also be used to model the environment's dynamics, which is crucial for planning and prediction.
Interesting. It sounds like these models are not just passive repositories of knowledge, but rather active participants in the decision-making process. Can you elaborate on the concept of behavioral priors or skills in this context?
Sure. Imagine a robot that needs to learn how to perform various tasks, like picking up objects or moving them around. Traditional RL approaches often struggle with this, requiring vast amounts of data and training time. However, foundation models can be used to learn these basic skills from diverse datasets of related actions. These skills, or behavioral priors, can then be combined to achieve more complex tasks. It's like having a library of pre-built blocks that can be assembled to create more intricate structures.
So they can be used to bootstrap the learning process, making it much more efficient. That's fascinating. Doctor, what are your thoughts on this approach?
I think it's a very promising approach. It addresses one of the major challenges in AI, generalization. By learning these basic building blocks of behavior, agents can potentially generalize to new tasks more effectively. This is a significant advancement compared to traditional methods that are often task-specific and require extensive retraining for new tasks.
Let's delve into the methodology section. Dr. Yang, could you explain how foundation models are used as conditional generative models in decision-making?
Sure. Conditional generative models are crucial for both modeling behaviors and world models. When modeling behaviors, these models learn to generate sequences of actions conditioned on factors like goals, rewards, or even past experiences. This allows for the discovery of new and potentially optimal behaviors that were not explicitly present in the training data. On the other hand, when modeling world models, these models learn to predict the environment's dynamics, allowing the agent to plan and reason about future outcomes. They can predict the next state, reward, and even the consequences of different actions.
So, in essence, they can predict the future based on the current state and actions. How does this compare to traditional RL methods that don't rely on models?
Traditional RL methods, especially model-free methods, learn directly from experience through trial and error. This can be very inefficient, particularly in complex environments where the agent needs to explore a vast space of possibilities. Model-based RL, which uses explicit models of the environment, is often more sample efficient, but it requires accurate models. Foundation models can offer a unique solution, providing both generative capabilities for modeling behaviors and world models, as well as learning powerful representations of states and actions.
Doctor, what are your thoughts on the use of foundation models as representation learners?
Representation learning is a key aspect of generalizing knowledge across different tasks and environments. Foundation models are very good at extracting meaningful representations from diverse data sets, including images, text, and interactive data. This capability can be leveraged to improve the efficiency and generalizability of decision-making systems. The models can learn compressed representations of states, actions, and rewards, making learning and reasoning more efficient.
Dr. Yang, you also explore the use of large language models as agents and environments. Could you elaborate on that?
Yes, that's a fascinating area. Large language models, with their ability to process and generate text, can be viewed as interactive agents. They can interact with humans, tools, or even simulated environments. For example, a language model can engage in dialogue with a human, learning to produce safe, factual, and helpful responses through feedback. This opens up exciting opportunities for developing more engaging and intelligent conversational agents.
This is really intriguing, especially the idea of language models as environments. Could you elaborate on that?
Sure. Think of it this way. A language model can be a computational environment that takes text inputs and generates text outputs. We can use this ability to create interactive prompting systems where we can guide the language model towards a specific goal through a series of prompts. This approach is especially promising for tasks that involve complex reasoning or problem solving.
So, by interacting with a language model through prompts, we can effectively use it as a tool for computation and reasoning. It's like giving instructions to a very powerful and sophisticated AI assistant. What do you think about this paradigm shift in how we interact with language models?
I find it very exciting. It's a step beyond just using language models as generators of text. It allows us to tap into their computational power for a wider range of applications. This could lead to advancements in areas like automated code generation, scientific discovery, and even creative writing.
Moving on to the challenges and opportunities discussed in your paper, Dr. Yang, what are some of the key issues that need to be addressed to fully realize the potential of foundation models in decision-making?
One major challenge is the data gap. We need to bridge the divide between broad datasets used to train foundation models and task-specific interactive datasets used in decision-making. For example, many video datasets lack explicit action labels and reward signals, which are crucial for training RL agents. We need to develop better methods for relabeling and augmenting datasets to make them more suitable for decision-making tasks.
That's a significant challenge. Dr. Persrode, do you have any insights on how to bridge this data gap?
One promising approach is to leverage the abundance of unlabeled video data available on the internet. By using techniques like hindsight relabeling, we can infer actions and rewards from videos, creating new training datasets. This could be a game changer for scaling up decision-making research.
Dr. Young, you also discussed the challenges related to the structure of environments and tasks. Could you explain this further?
Yes. Decision-making systems often operate in diverse environments with varying state action spaces. This makes it difficult to generalize knowledge across different tasks. For example, a robot that learns to navigate in a virtual environment might not be able to easily transfer that knowledge to a real-world environment. We need to develop more generalizable frameworks for unifying state action spaces, perhaps by using text as a universal interface or by representing policies as videos.
It sounds like these issues are tightly intertwined with the data challenges you mentioned earlier. Dr. Field name, are there any additional technical hurdles that need to be addressed for foundation models to be truly effective in decision making?
Absolutely. Current foundation models often struggle with long contexts and external memory. They have limited ability to reason and act over extended periods. This is critical for tasks that require complex planning or remembering past experiences. Research is needed to improve their capacity to process and utilize information over time. Furthermore, we need to develop better ways to combine multiple foundation models, each capturing different modalities of knowledge, to create more powerful and versatile agents.
That's a very important point. Dr. Yang, could you talk about the ethical considerations involved in applying foundation models to decision making systems?
It's crucial to address the ethical implications of this research. We need to be mindful of potential biases, fairness issues, and safety concerns. For instance, we must ensure that these models are not used to perpetuate discrimination or harm. We need to develop mechanisms to prevent these models from being used for malicious purposes.
How do you see these advancements shaping the future of AI?
I believe that foundation models have the potential to usher in a new era of AI, where agents can not only understand and reason about the world, but also interact with it in a meaningful and intelligent way. This could lead to breakthroughs in robotics, healthcare, education, and many other fields. However, we must proceed with caution, ensuring responsible development and deployment to maximize the benefits while minimizing the risks.
Dr. Yang, what are some of the most promising future directions for research in this field?
We need to continue to develop methods for bridging the data gap, for example, by leveraging unlabeled data and developing more effective relabeling techniques. We also need to explore new ways to structure environments and tasks to enhance generalization. Improving the ability of foundation models to handle long contexts and external memory is critical, as is developing techniques for composing multiple foundation models to create more powerful agents. And finally, we must address the ethical implications of this research, ensuring that these powerful technologies are used responsibly and for the benefit of humanity.
Dr. Yang, Doctor, thank you both for this insightful conversation. This exploration of foundation models and their potential in decision making has truly illuminated the exciting possibilities and challenges that lie ahead. It's clear that this research has the potential to reshape the landscape of AI, leading to more intelligent and capable agents that can interact with the world in meaningful ways.
Thank you for having me.
It was a pleasure discussing these topics with you both.